Okay, so now we will be discussing the problem cyclic rotation in the basic arrays category. So the problem is given a array of n integers and an integer k, what we have to do? We have to rotate the array k times in clockwise order. So given an array and given an integer k, that there's a number of rotations. What we have to do? We have to rotate that particular array in the clockwise order. What do you mean by clockwise order? If I am saying the array is 1, 2, 3, 4, 5. If let's say this is the array that is having 5 elements n equal to 5. Let's say I want to rotate for one time. So what will be one time rotation in clockwise order? Clockwise is this. So what we have to do? We have to make one rotation from right towards the left. That is, after the rotation, what will the new array become? The new array will be 5, 1, 2, 3, 4. This is after first rotation. Similarly, what will happen after second rotation? If k is equals to 2, we can say one more time, rotate the last element and bring it in the front. So the remaining array or the resultant array will become 1, 2, 3, 4 shifted, and then in the front we have 4, 5. So 4, 5, 1, 2, 3. This is the answer after two rotations. Similarly, if I ask you what is the array after three rotations, the array after three rotations will be the last element, which is nothing but 3, will be rotated in the front. And if it is rotated in the front, what will the array become? It will become 3, 4, 5, 1, 2. And you can repeat this procedure again and again for more number of rotations. So if I say for k equal to 4, what will happen? Obviously, now you can easily say that we will be having 2, 3, 4, 5, and then lastly 1. But what will happen for the k is equals to fifth rotation? For k is equals to fifth rotation, if I will say that in this array, rotate the last element. So what will be the rotation of last element? 1 will come in the front. And what will be the array? The array will be 1, 2, 3, 4, 5. So actually, I will get the same array back which was there in the input. So if a array is of n size, the fifth rotation or the nth rotation will be going to give the same array back which was there in the input. So this is also a observation. And let's now read the sample input, sample output. So in the input format, what we are given? We are given that there will be 3 lines of input containing first of all the integer n, that is the size of array. Then there will be n space separated integers, that is the array elements, and the value of integer k, that is how much rotation we need. So if our array is of 5 size, if the elements in the array are 1, 2, 3, 4, 5, after second rotation, what will be the array? 4 and 5 will come in the front, 1, 2, 3 will go in the back. And you can see the explanation also. That is after the first rotation, array will be 5, 1, 2, 3, 4. After the second rotation, array will be 4, 5, 1, 2, 3. And the constraints can be array can have maximum number of 10 raised to power 6 elements actually. So 10, 1, 2, 3, 4, 5 actually, not 10 raised to power 6, but 10 raised to power 5 elements. And each array element will be from 1 up till 10 raised to power 5 again. But the k value, it is minimum 0. So we can have 0 rotations. If we are having 0 rotations, it means we are not rotating at all. If we are not rotating at all, then we are saying that array will be the same. Or the number of rotations can also be at max 10 raised to power 5. That is maximum we can rotate the array for 10 raised to power 5 times. So it is not necessary that the array rotations will be less than or equal to n. It is not given. We can have number of rotations even more than the array size. That is, if let's say we are having the same array having 5 elements, we can rotate this array for 6 times also, for 7 times also, for 8 times also. These can be the input. So we have to take care about these corner cases also. So now that we have discussed the problem statement, that actually what is the question asking us to do, and we have discussed certain test cases, we will now be jumping on towards the second module. That is nothing but finalizing the approach and going up from the brute force solution. So what can be the most basic solution which we can think of? The most basic solution which comes to my mind as a simple intuitive thinking is rotate one at a time, rotate one at a time, rotate one at a time. That is, if we are going to do k rotations one at a time, it will rotate the array for k times. So if I just do a try run, a proper quick try run for the brute force code. So if let's say I am saying the array is having some more number of elements, let's say the elements are 10, 20, 30, 40, 50, 60. Let's say there are 6 elements. We are having the array values not 1, 2, 3, but 10, 20, 30. It can be anything. And let's say the k value, that is the number of rotations we need to do, is 3. We need to rotate for 3 times. So what we need to do for this brute force approach, we are rotating one element at a time. And if we are rotating one element at a time, how can I rotate a single element? That is, how can I make the last element come in the front? See, if you are directly going to update 60 and make the array of 0 as 60, you will be losing the value of 10. 10 value will be lost. Similarly, if you are now going to say that I want to update it with 10, you are not having the value of 10. So instead of first updating the value of 10 with the new value, which is 60, what should we do? We should first store this 60 value in some temporary variable. Let's say temporary variable is temp. I am saying the last value which we need to make it in the front is array of n minus 1, array of size minus 1, and it will be 60 in this case. So store it in a temporary variable and now do the shifting. So what will be the shifting looking like? Should I first shift 10 towards 20? No, I will be first shifting 50 towards 60, because after rotation, 60 will come in the front and all these elements will be shifted one position to the right side. So first make the 50 element take the place of 60. That is, this will become 50. Then make the 40 take place of 50. Then make the 30 take place of 40. Similarly for 20 and similarly for 10. And now after all the shifting is done, now we can easily make the new element, that is a temporary value, which we have rotated, come in the front. That is 60 will come in the front. But this is for one rotation. We will repeat this procedure for k times, because k was 3. So I will be repeating this procedure for k times. That is, now again, I will store this time temporary as an array of n minus 1, which is now not 60 but 50, and do the shifting. This will become 40, this will become 30, this will become 20, this will become 10, this will become 60, and the array of 0 will finally become the new value, which is 50. Similarly for the third time. So this is how we can rotate. So let's not have the try run for k is equals to 3. It will be very long. If there will be some number of rotations, what is single rotation taking? How much time complexity? It is taking order of n time complexity. Why? Because I am running a loop and shifting all the values. But for single rotation, for one element being rotated and coming in the front, it is taking linear. If I am going to rotate for k times rotation will take order of k into n, because it will be like n plus n plus n k times. And what will be the space? Actually, I am not going to take any extra space. So space will be actually constant. Why? Because we are doing it in place. We are not making a new array. We are updating the same array itself. So it is kind of quadratic time complexity k into n. Can we reduce the time complexity? Most probably this will give time limit exceeded. So is there any better way to do this rotations? We can say, what if we have a new array? What if we are allowed to create a new array? If we are allowed to create a new array, then most probably we can think directly in terms of k rotations, not one rotation at a time. So the first optimization which I can think of is nothing but directly creating a new array. So if you do not know about the array traversals or array creations, first you have to learn that concept, and then only you will be able to come up to this optimization. So let's say the input array was 10, 20, 30, 40, 50, 60. And what we wanted to do, we wanted to rotate for k is equals to 2 times. So if we wanted to rotate for k is equals to 2 times, that is the final array, what we need the last 2 elements should come in the front. That is 50 as well as 68 should come in the front, and remaining all the values should go in the last. That is, they will be shifted in the right side. So if this is the input having 6 elements, this is the output also having 6 elements. First of all, what we are saying, create a new array with the same size, that is with the 6 elements. But initially it will be obviously containing zeros, because the default value of integers in most of the programming languages are 0. By default, every integer will be 0. And what we are going to say, I am going to make all the last elements which we are about to make them in the front get stored in the front hand side. That is, I will run a loop over all the values for the last k elements, and I will bring them in the front. And then the second iteration will be all the remaining elements, I will be making them go in the last. So if I just now run a loop on all the remaining How many elements? If these are k elements, k is equals to 2. So what are the number of remaining elements? It will be n minus k. That is, in this case, 6 minus 2, which will be 4 elements. So now I will be running a loop over all the elements from 0 till less than n minus k, all the indices from 0 to 3, and just store them in the remaining array, in the remaining resultant. And in this fashion, so this resultant was only of 6 size, not 6 index will exist. I will be able to shift for k times, because now I am able to rotate for k times only once. And now in this case, what is the time complexity which we are using? Since first I am running a loop on all the k elements and then all the n minus k elements, overall time complexity will be k plus n minus k, that is still order of n only. So previously it was n into k, but now it is n minus k plus k, that is only n, order of linear. So what about the space complexity? Are we using any extra space? Yes, that's what we discussed. We have created a new array. And if we have created a new array, we are taking an order of n extra space due to the new array we are about to create. So this is the first particular optimization. We can easily code this. Most probably everyone should be able to code this, but is there any even better further optimization possible? And for even further optimization, we should know that how we have to do the reversal of an array. If we know how to reverse an array, then we will be able to optimize further. So the second possible optimization, let's try to come up to the approach. Let's try to come up to a certain observation. It is a purely observation or a pattern based optimization which we are about to discuss. So again, what we are doing is, let's now this time take a bigger array, even bigger array. Let's take a 7 size array so that observation is clearer. Let's take 7 elements in the array and let's take the number of rotations which we need to perform is k equal to 3. I need to perform 3 rotations. So what will be the resultant after 3 rotations? The resultant after 3 rotations will be 70 will come in the front, then 60 will come in the front, then 50 will come in the front. That is 50, 60, 70 will go in the front. But all the remaining elements will go in the right side. That is 10, 20, 30, 40 will go in the right side. So if we are about to compare the input with the output, what is the order of last k elements? The order of last k elements is same. If it was 50, 60, 70, it is still 50, 60, 70. And for the elements of the order n minus k, for the remaining n minus k elements, what is the order? It was 10, 20, 30, 40. It is still 10, 20, 30, 40. It is still the same. So if we are doing a reversal 2 times, if we are going to do reversal 2 times, order will be same. If I am giving you array 10, 20, 30, if I ask you to rotate it or actually reverse it, what will be the array? 30, 20, 10. And if I again ask you to reverse it, what will be the new array? The new array will be 10, 20, 30 back, because 2 times reversal will give me the same array back. So what we have to do? We want 50, 60, 70 to be in the same order, but in the left hand side. Similarly, 10, 20, 30, 40 in the same order in the right hand side. So what we can think is, we can maybe do reversal twice. Once for the n minus k elements, once for the k elements, and then we have to think that what will be the intermediate array. So if I rotate or if I actually reverse the starting n minus k elements, what will be the array? It will be 40, 30, 20, 10. What if I reverse the last k elements? So if I reverse the last k elements, it will become 70, 60, and 50. But this array and the resultant array, this red array and the blue array, how I can convert the red array into the blue array? If you carefully observe, as we discussed, that 2 times reversal will give me the same array back. If I see this array from left to right, or if I see this array from right to left. Similarly, even if I see this array from right to left and I see this array from left to right, it will be actually the same. So the next part is nothing but reversal the entire array, reversal of the entire n elements, starting from the starting index going till the last index. So what are the 3 points? First point is reverse the starting n minus k elements. That is, if we talk in terms of indices, we are reversing the indices from 0 till third index. So left pointer will be 0, right pointer will be third index. Left till right, we are going to reverse only this much part. Only this much part. Then second time reversal will be for the last k elements. That is, if I talk about the particular example, it will be from 4 to 6, from 4 to 6, and then actually reverse the entire array. That is, reverse the array from 0th index up till the last index, from 0th index up till the 6th index. But if we talk in general, what will be 3, what will be 4, what will be 6? I can say 0 till 3, 0 till all the numbers in n minus k elements. So what will be the last index if I am saying n minus k elements? It will be n minus k minus 1. So last index will be n minus k minus 1. That is, if n was 7, k was 3. So n minus k minus 1 will be 7 minus 3 minus 1. That is the third index. What about 4? You can say this is n minus k only. It is actually equivalent to 7 minus 3, which is 4. What about 6? This is the last index of the array, n minus 1. Again, 6 is nothing but n minus 1. So first, reverse the starting n minus k elements. Then reverse the last k elements. And then actually reverse the entire array. If we are going to follow these 3 steps, we are able to rotate the array by k points. And in how much time complexity? Reversing n minus k elements will be taking order of n minus k times. Reversing k elements, last k elements will be taking order of k times. And reversing the entire array will also be taking order of n time. So overall time complexity will be n minus k plus n. It will be k getting cancelled with k. So n plus n, it will be 2n. So 2n is still linear because we generally do not ignore, we do ignore constants. We do not take constants. So it is linear in nature. And what about the space? Are we using any extra space? If we are going to do reversal, it is going to be constant because reversal only requires the 2-pointer logic. So the space is constant, or you can say in place logic. We are not taking any extra space. So this is the best possible fashion in which we can solve this question. Linear time, constant space solution. So now that we have discussed this optimization, let's now jump onto the instruction manual. So first step, what we need to call 3 functions. So let's have a same function only. Let's have the function reverse. So static reverse will not return anything. So static void reverse, where I will be passing the array, where I will be passing the left and the right pointers, both the pointers, the starting index of the subarray which I want to reverse and the ending index of the subarray which I want to reverse. And in this function, we need to basically apply the reversal logic. So how we can apply reversal logic? We can apply reversal till the point left is smaller than right. So we can say run a loop, run a while loop preferably up till until left is smaller than right. Left is smaller than right, because if there is a subarray remaining, if left is smaller than right, then we can swap the elements. So till this point, what we have to do? Swap the array values present at which 2 indices? At arrays left index and right index. Arrays left index and right index. For this, you should know how to reverse, because reversal we have already covered. You have to now only implement it in a particular subarray from left to right. Once we have swapped the values from left index with the right index using some inbuilt function, you can use any inbuilt function provided to you in your particular programming language. Now what we have to do? We have to swap the next 2 pairs. If I give you a quick example, let me say there is an array 10, 20, 30, 40. If we need to reverse it, what we have to do? We have to first swap 10 with the 40. So it will become 40, this will become 10. And then left plus right minus swap 20 with 30. This will become 30, this will become 20. So we now have to increment left and decrement right by 1. Increment left by 1 and decrement right by 1. Up till which point? Up till the point till the loop runs. So once the reversal is done, once we have written the code, in the main actual logic, we are just going to call it for 3 times. So I am going to call this function, call the function reverse for array in the range 0 up till n minus k minus 1, where n is the array dot length. So initialize, we can maybe initialize n as array dot length, or it is given in the parameter itself. Then call the reverse function, or you can say reverse the part, call the reverse for array in the range that is nothing but n minus k up till n minus 1. That is pass left as n minus k and pass right as n minus 1. And then finally call the reverse for the array entire, that is from 0 to n minus 1. Once we have called these three functions, what we need to do? We can return the same array itself because we are not using any extra array. So last point will be return the same input array, that is ARR. So this is nothing but the pseudocode. But one point which is still remaining is nothing but what do you think will be a corner case when the number of rotations will be more than the number of the elements in the array? What will happen if the k will be more than n? If k will be more than n, then this logic will fail. Why? Let's see. If I am having an array with 4 elements, if I'm having a, let's say, k value 5. So what we are saying in this logic? We are saying first reverse the 0 up till n minus k minus 1. So what is n minus k minus 1? It is 4 minus 5 minus 1. 4 minus 5 minus 1 will become how much? It will become minus 1 minus 1 minus 2. So there is no minus 2 index. So this negative index will not exist. Or even if you want to apply it, it will go into index out of bound. So if k is more than n, what should we do? Actually, we should reduce the value of k. How we can reduce the value of k? As you can clearly see, after the 0th rotation or the 4th rotation or the 8th rotation or 12th rotation, array will be same. Similarly, after first rotation, 5th rotation, 9th rotation, 13th rotation, array will be same. Similarly, for second rotation, the 6th rotation, 10th rotation, 14th rotation, and so on, the array will be same. Why? Because if we are rotating for 4 times, it is equivalent to not rotating at all for an array of 4 size. If we are rotating for 4 times, we are not rotating at all. Same goes for third rotation or 7th or 11th or 15th. It is one and the same thing. So how we can go to the value of 0, given value of 4, 8, 12, 16, all the multiples of 4, all the multiples of n. We can say this is nothing but k modulus n. This is nothing but k modulus n. 5 modulus 4 will be 1, 9 modulus 4 will be 1, 13 modulus 4 will be 1. So reduce all the bigger values into smaller values by updating the k as k modulus n. That is, if we are given 12 rotations, we will not do 12 rotations. We will say we will do 12 modulus 4, 0 rotations. If we are given 13 rotations, we will not do 13 rotations because if we are going to do 13 rotations, it will be index out of bound. We will do 13 modulus 4, which is only one rotation. Only one rotation we can do. We can have n minus k and k elements, or you can say this is k, this is n minus k. So first, before applying these 3 points, these 3 reversals, first step we should do is update k as k modulus n to reduce the value from reduce the value in the range 0 till n minus 1 to reduce the value. Now the code will be complete. What we have to do, first of all, code the reversal part. That is, we have to run a while loop up till the point left is smaller than right. You can also run the loop even till left is equal to right, less than equal to, but left smaller than right will also work. What we have to do every time, swap the array values present at left index, present at right index. So in order to swap those values, we can use any inbuilt function, or you can also actually write your code yourself. You can write the code exactly here. That is, let's take a temporary variable at array of left, make the array of left become array of right, and then array of right will become temp. So it is your choice whether you want to use any inbuilt function or not. Once we have swapped the values present at left and right pointers, what we have to do? Increment left by 1, that is left plus plus, decrement right by 1, that is right minus minus. So this is the reversal code from a subarray left till right. In the main logic, what do you have to do? First of all, reduce the value of k so that it becomes in the range 0 till n minus 1. So that index out of bound does not happen. Once we have updated the value of k, now we need to call the reverse function for 3 parts. First, from 0 up till n minus k minus 1. Then reverse from n minus k up till n minus 1. And finally, the entire array. It was purely based on observation that we have done in the last particular video. So finally reverse the entire array. Once we have reversed these 3 parts one by one, we will be returning the entire input array, exactly same array, because we are not taking any extra space. So if we run this logic on the sample input, let's see what will happen. And then we will check for the corner cases. So this code is running for the sample test case. If we are doing two rotations, 4 and 5 are coming in the front, 1, 2 are 3 are going in the right side. Let's say we are having 5 values, 1, 2, 3, 4, 5. We are not doing any rotations at all. Number of rotations is 0. What will be the output array? Output array will be the same input array itself. That is 1, 2, 3, 4, 5. Let's see if it is the same array or not. Yes, it is the same array. Even if I do 5 rotations for an array of 5 size, what will be the answer? 5 modulus 5 array should become 0 rotations. That is same array itself again. So let's see if it is the same array or not. If it is going to give me the same array for 5 rotations. And it is running, it is taking some time. Yes, it is giving me the same array. What will happen for, let's say I am saying 10 rotations, or maybe not 10 but 9. 9 rotations will be equivalent to 9 modulus 5, 4 rotations, because 5 rotations will be just a waste. So 4 rotations will be 2, 3, 4, 5 in the front, 1 in the last. So output should be 2, 3, 4, 5, 1. Let's see if it is going to give me the same output or not. And it is actually giving me. So let's submit this. And if it is going to work fine, then what was the time complexity of this problem? The time complexity was linear. What was the space complexity of this problem code? The space complexity was nothing but constant, because we are not taking any extra space. We are doing it in place. Are there any follow-ups which you can solve this for this problem, which can come in an interview? Surely yes. What if the rotations are not leftwards, actually not rightwards, not clockwise? If they are leftwards, that is, they are in the anti-clockwise direction, then what will you do? You have to think in terms of that. That is negative rotations. How will you handle the negative rotations? Maybe if k will be -1, k will be -2, k will be -3. You can think in terms of that. One more problem can be reversing a 2D array, a matrix. How will you be able to reverse a 2D matrix using the same logic? So once you have learned those concepts, you can go through those questions also, that is reversing in anti-clockwise direction. And once you learn 2D matrix, you can solve a problem based on reversing a 2D matrix, or you can at least think of the time and space complexity.